Stop looking at the sky for Terminators. The real threat to humanity isn't made of cold metal. It is growing quietly in a petri dish right now. In the next 10 minutes, I am going to show you why the age of silicon is dead and why the future of computing is flesh. You are about to witness the birth of DishBrain, a cluster of living neurons forced to play video games to survive. We will uncover the dark reality of Wetware, server farms built not from hard drives, but from living biological tissue. We will look into the abyss of a future where the Metaverse is powered by enslaved consciousness, and we will ask the terrifying question, if your computer has a biological brain, can it feel pain? Forget ChatGPT. This is the rise of Organoid Intelligence, and it might be the last mistake humanity ever makes. To understand this nightmare, you must first understand why the Silicon Age is dying. For decades, we relied on Moore's law, shrinking transistors to microscopic sizes, but we have hit the physical wall. Our current supercomputers are becoming ecological disasters. Machines like the Frontier supercomputer consume 21 megawatts of power, enough to drain the life from a small city just to run simulations. We are burning the planet to fuel our hunger for data. Silicon is hot, inefficient, and stupid. It requires brute force to work. Nature, however, solved this problem billions of years ago. The human brain operates on just 20 watts of power, barely enough to dim a light bulb, yet it outperforms every supercomputer on Earth. Desperation has led scientists to a terrifying conclusion. If we can't build a better computer, we must harvest one.
This is not theoretical science fiction. The monsters are already here. In a laboratory in Australia, a company called Cortical Labs created DishBrain. They took 800,000 living neurons, some from mice, others derived from human stem cells, and connected them to electrodes. Then they forced this cluster of cells to play the video game Pong. But they didn't write code, they conditioned it. When the cells missed the ball, they received a chaotic, unpleasant electrical pulse. When they hit the ball, they received a predictable, rhythmic signal. It was a digital version of the stick and the carrot. In 5 minutes, the flesh learned. It learned faster than any AI ever could. It wasn't just processing, it was adapting. It was living matter learning to survive in a digital simulation. Here lies the tragic irony of our technological evolution. We are moving from the era of software to the era of wetware. Imagine a server farm 10 years from now. Gone are the rows of blinking LED lights and the hum of cooling fans. Instead, you walk into a humid, warm room that smells of iron and saline. Inside the racks are not hard drives, but glass canisters filled with nutrient-rich pink fluid, keeping millions of tiny lab-grown brains alive. These biological processors will run the internet, manage the stock market, and render the metaverse. We are creating a caste of biological slaves, living processors that exist only to serve our digital whims, stripped of a body, stripped of senses, left only with the capacity to compute. The technical advantage is undeniable, but the chaos it invites is existential. Silicon is binary. It is 0 or 1. It is predictable. Biology is chaotic, probabilistic, and messy. When you build a computer out of living cells, you introduce the variable of life. These organoids form neural pathways just like a developing fetus. At what point does a processor stop being a tool and start being a being? If these organoids can learn, can they feel? If we punish them with electrical noise to make them calculate faster, are we torturing them? We are building a global network based on the suffering of microscopic biological entities. We are creating a machine that might essentially be screaming in silence, forever trapped in the darkness of a server rack. Let's connect this to the Metaverse, the digital reality we are so eager to build. Today, the non-player characters, NPCs, in video games are scripted bots. But with Organoid Intelligence, the NPC you talk to in the virtual world could be powered by a real biological brain structure housed in a data center thousands of miles away. It would have memory, it would have intuition, it would have a ghost in the machine. We are blurring the line between a simulation and reality so aggressively that we might accidentally create a digital hell. Imagine interacting with a virtual character that isn't programmed to act human, but is biologically struggling to understand its existence. This isn't advanced AI, this is trapped consciousness.
The ultimate goal of this technology isn't just better computers, it is the integration of this wetware with us. Biocomputing is the bridge to transhumanism, but not the utopia we were promised. We are looking at a future where memory expansion isn't a USB drive, but a grafted tissue implant. The chaos begins when the interface fails. What happens when the biological processor rejects the host? What happens when the living computer develops a neurodegenerative disease? We are inviting biological decay into our digital immortality. We are trying to become gods by stitching together Frankenstein's monster piece by microscopic piece, hoping it won't turn against its creators. We have opened Pandora's box, and we cannot close it because the economics are too good to ignore. Biological computers are millions of times more energy efficient than silicon. The corporations that control the future will not care about the ethics of brain-in-a-jar technology, they will care about the bottom line. We are marching toward a future where the internet is alive, where the cloud is made of meat, and where our smartest machines are our own distant biological cousins. We feared AI would destroy us with weapons. The reality is far more tragic. We will destroy the sanctity of life by turning it into a component, a spare part, a battery. The machine isn't coming for us. We are becoming the machine.